Another popular method to overcoming overfitting by reducing dimensionality is feature reduction. These principal components will be orthogonal. In other words, they would be independent. The difference between feature selection and feature reduction is that feature selection is directly to eliminate original features, while feature reduction is to map the original high-dimensional feature space to a low-dimensional space, where the dimensions of the low-dimensional space is predefined. Generally, methods of feature selection can be classified into two categories, linear and nonlinear. The data transformation may be linear, as in principal component analysis (PCA), but many nonlinear dimensional reduction techniques, such as autoencoder, also exist. On the other side, it can be classified into supervised and unsupervised regarding ground truth. This section will focus on PCA. These principal components would be orthogonal. In other words, they would be independent. It performs a linear mapping of the data to a lower dimensional space in such a way that projection distance in the low dimensional representation are maximized. The circles in this figure are samples in the data. If we project these samples along with V1, we can observe that the sum of projection distances are larger than that projected along with V2. Principal components, PCs, are orthogonal vectors that are ordered by the fraction of the total information in the corresponding directions. PCs can be found as the best eigenvectors of the covariance matrix of the data points. PCs are linear least square fits to samples, each orthogonal to the previous PCs. First, PC is a minimum distance fit to a vector in the original feature space. Second, PC is a minimum distance fit to a vector in the plane perpendicular to the first PC. Here are some points of mathematics for PCA, such as how to estimate covariance matrix from data points. Here are the detailed steps to obtain PCs, where the input is an n by d data matrix X. 1. Calculate the mean of data. Mean values of data points is subtracted from rows of data. 2. Calculate the covariance of data. Calculate eigenvalues and eigenvectors of the covariance matrix. Pick eigenvectors corresponding to the largest eigenvalues based on a predefined dimension k and put them in the columns of E such that k is less than d. The resulting output, x prime, is the PC. Let us use one example to check how to use PCA to implement feature reduction. Two features for this data exist: 1. House price and 2. House area. We calculate the mean of each feature such that house price mean is 4.6 and the house area mean is 4.6. We centralize the features by subtracting the mean. The instructor will show you the details on the explanation of calculations. Calculate the covariance. The instructor will show you the details on the explanation of calculations. Calculate eigenvalues and eigenvectors of the covariance matrix with SVD on the covariance matrix. The instructor will show you the details on the explanation of calculations. We then pick eigenvectors. The instructor will show you the details on the explanation of calculations. We can obtain PCs. The instructor will show you the details on the explanation of calculations. If we do clustering on the original space, it is not obvious to group S4 and S1 into one cluster. If we do clustering with PC1, it is easier to group P1 and P4 into the same cluster if the clustering rules are below. If Pi is less than 0, then Pi belongs to C1. If Pi is greater than 0, then Pi belongs to C2. Thank you.